Hello, everyone, and welcome to Community Central Tech Tuesdays. Today we have with us Joey Schorr, the co-founder of Quay.io, who's going to talk about the history of container registries. If you've used Docker, if you've used Kubernetes, these are the container management systems you have used a container registry. Joey helped build the first one that was independent of Docker Hub, which then led to a bunch of others. So before we get started, for people for whom this is the first Community Central, I wanted to remind you that on your screen should be a Q&A pane. If you have a question for Joey, please post it there in the Q&A pane, and we will hold it to the end. If you see a question there that you like, please upvote it. We'll be selecting the most upvoted questions first. Everyone is welcome to say whatever you want in the chat that is reasonable within a code of conduct, but we won't necessarily see questions you ask there. With that, let's go ahead and get started. Joey, you want to take it away and start out with a little history?
Absolutely. Thank you, Josh. Good morning, everybody. My name is Joey Schorr. Happy Easter or Chag Sameach to everyone who's celebrating those. And my talk today is going to be about container registries then and now. It's going to be about a history of the container registry APIs, how Quay was developed, how its data model involved, some of the challenges we faced along the way. This talk is going to be technical in nature, but I'm going to try to give high-level overviews wherever possible. If you have any technical questions, please don't hesitate to put them into the chat, and we will get to them at the end. And I'll be happy to give a deeper dive or additional history as necessary. So, who am I? My name is Joey Schorr. I'm the lead engineer and co-founder of Quay. For those who have watched Stargate, that is my icon on GitHub, but is also Anubis. I'm not actually a Goa'uld, but I am a system lord, or I suppose a lord of systems, I suppose, because Quay is a complex system and we've built it over time. And what the heck is Quay? Really, don't know? Well, you should. Quay and its open source upstream project Quay, is Red Hat's hosted and on-premise container registry, which you can find as Project Quay now. In fact, Quay, as Quay.io, was the first ever private container registry created. We actually preceded Docker Hub in that sense. There was the public Docker index, but we were the first private one. A quick aside on how we got here as a project and product. Quay started as part of a startup that I co-founded called DevTable LLC. That company and product was acquired by a startup called CoreOS that we worked at for a number of years. CoreOS itself was acquired by Red Hat in January of 2018, and then there was another acquisition somewhere in there. But as you can see, we've been through a lot of different companies. It's actually been 4 companies for the same product, which is probably a record somewhere. It's been a really great journey through there. So what's so complicated about container registries, right? On theory, this should be simple. Container registries actually have a lot of history, and this can lead, if you're trying to support backwards and forwards, to a lot of complications. So let's prep the time machine and dive right into the history. There's our time machine. September 2013, dawn of Docker. In September of 2013, Docker had just been released earlier that year in March and was on version 0.7. So you can see it's been a very long time. It's been nearly 7 years now. And along with the early releases of Docker, Docker had launched something called the Docker Public Index, which had been created as a way of exchanging public images. So this is when you would do a Docker pull of something like Ubuntu. It would go out to the Docker Public Index using an API, which I'll talk about in a moment, and it would allow for downloading of those standardized images. And anyone could actually upload these public images, but the key word was public. But before we talk about that, let's start by saying, what are these terms? What is an image? I should note that the definition of the terms I'm going to say now are per the Quay team. Other companies, others in the community use terms slightly differently at times, which can lead to a lot of confusion. That's part of the reason why I'm going to give a quick set of definitions as a way of ensuring everyone's on the same page. So terms and meanings for our team and for the duration of this talk. An image, a unit containing the configuration and file system for a container to be run. You'll sometimes hear this called container image. You'll sometimes hear this called a container. The image is a unit containing the configuration and file system for a container to be run, while a container itself is the running object. Tag, a named reference to an image. Latest, my project, version 3.6, something like that. Repository, a named set of tags. Some other projects and members of the community will use the term registry to mean a named set of tags, or they'll use a repository to represent the entire set of all of the repositories themselves. In our team's parlance, a repository is a named set of tags, which lives under a namespace, which is a named set of repositories. And then finally, at the top level, you have the registry, a system that stores container images. And this is important in terms of hierarchy because it allows for definition along the way. So, what actually is an image? As mentioned, an image is a bundle that contains the run configuration as well as the file system information for running a container. Pointing to that is a tag, like latest. You can have another tag called other, pointing to another image. The set of those tags and images can live inside of a repository, of which you can have multiple. And you can have the same tags with the same names in different repositories. And those repositories, in turn, live within a namespace. And finally, that namespace becomes the registry. Now that we have those defined, let's talk about the history of the registry. So as mentioned, in September 2013, Docker Registry and the protocol had been introduced slightly earlier in the year in support of the Docker public index. This API supported pulling and pushing images to a registry, Docker public index. Unfortunately, there weren't any private registries available. If you wanted to store images that contained your own code that wasn't open source or other forms of sensitive information, you could either run your own copy of the registry on your local machine or on a server somewhere and write your own auth in front of it. A lot of people would put HTTP basic auth in front of it. Or alternatively, you could just make sure that you didn't have anything sensitive in the images and push it to the Docker public index. Recognizing this problem, we created Quay. For a little bit of history here, the product that we were working on at the time was actually a web-based IDE, and our users were making use of custom-tailored environments. And we were running Docker containers to provide SSH access to those custom environments. Since those environments were custom, they contain proprietary code, and so we couldn't push it to the Docker public index. So we originally decided to stand up a copy of the open source registry in order to address that issue, and quickly realized if we have this problem, perhaps others on the internet do as well, and so we created Quay. The old saying, eat your own dog food, never really applied more than here. Quay.io was the first ever private Docker registry, as I mentioned. It was launched in October 2013 as a hosted SaaS at Quay.io. We actually launched it at the Docker meetup in New York City. There was one other presenter there that evening, which was actually a man by the name of Alex Polvey, who's CEO of CoreOS. Little did we know that the friendship we made with him that night would ultimately lead us to becoming part of CoreOS down the road, and now Red Hat. It's very fortuitous. And now, as mentioned earlier, Quay is now available as an open source project at projectquay.io. We open sourced last fall. This was part of our commitment as being part of Red Hat to open source. And all of our development since has occurred in the open. And in fact, during this talk, there will be a few references on the bottom of the slides to specific implementations or PRs that you can follow once you get a copy of the slide deck later, if you're more interested to see more of the history. How did this all actually work? Well, let's talk about the registry API, starting with Docker V1 Registry API. The Docker V1 Registry API was based on the concept of images, tags, repositories, and namespaces. And for those who may have noticed, these are familiar terms. In fact, that's where we got the terms originally. It was designed for simplicity of implementation and conformed to a RESTful API spec. So very basic operations, making use of HTTP verbs such as post, get, put, delete, etc. So let's just dive into an example, pulling a tag. Step 0, is this a Docker registry? The very first thing a Docker client would do when you wanted to execute an operation is issue a GET request against /v1/_ping. And this would allow the client tooling to determine if it was talking to a Docker registry. Any tool that did not return 200 OK and the literal word true would not be considered a compliant Docker registry. And this was just a very basic discovery check to ensure that if you were using a Docker client and you were trying to push to or pull from a registry, that it was actually a registry. Mentioned every registry call would start with this. The next one would be find the image for the tag. As mentioned, a tag is a named reference to an image. So if we're pulling a tag, what we're actually asking the system to do is resolve that named alias to the actual image that we're trying to pull down. So we're trying to find the tag latest. We actually want to pull the image that latest points to. So we called get /v1/repositories with your namespace, your repository name, and /tags. Wait, we forgot auth. Oops. Actually, we would actually have to put an authorization header there. The authorization header used in Docker V1 was very basic. It was basic auth. You give the username and the password, and you encoded it. You request a list of the tags, and you get back a JSON block that had all of the tags in the repository pointing to their image ID. Now, for those who are looking at this and wondering, how does this scale? The answer is, it doesn't. If you get past more than maybe a couple hundred tags, generating that block or even returning that set of data is just not going to work. So Docker added a new endpoint to the V1 API. Instead of requesting the whole set of tags, you could request specific tag by name, and you would get returned the image ID. And yes, note, that is actually a JSON string that it's returning. It's literally quoting. This was the first example of Docker making iterative changes to their API, and this would be a trend that would continue over time. Part of the reason why Quay as a product and as a project has been a complicated endeavor, and what is the core of this talk, is Docker has routinely made improvements to their APIs and data formats over time, as they should. But Quay has a commitment, and we are still the only enterprise-grade container registry that has this commitment, which is we support all the older versions of the protocols so long as our customers need it. So even today, if you were to use a modern version of Red Hat Quay 3.2 and 3.3, which is coming out next month, you can push an image into our product using the latest and greatest version of Docker, Podman, or any other compliant tool. And you can go and pull that image using Docker 0.7 when it came out, as it was written when we first started the project in October 2013. And that commitment is very strong on our part, but it also means that we have to support all these different versions of all the different APIs. And you can see, even just very early on, we already had to support two different means of retrieving tags from the registry. So we've gotten our image ID, and now we know which image to pull. Next up, retrieve the image's configuration. As mentioned, the V1 API is pretty RESTful, so it's just make a request to retrieve the image JSON for that image ID, and you get it back. Wait a second. What happened to the namespace in our API? It's actually gone. Docker V1 does not namespace images. So if we go back and look at the request here, you'll see it's /v1/repositories/images. There's no namespace here. There's no repository. In fact, all we're doing is requesting an image from the global image store with that ID. So the original Docker V1 protocol, as mentioned, does not namespace images. This means that if an image ID is shared across repositories or namespaces, it will actually be universally accessible. And this is actually a problem for a number of reasons. The biggest one being, this actually led to a pretty severe security hole in Docker registries when first identified. So for some background and history, those image IDs were not content addressable. They were not generated in a secure manner. They were essentially random, but not using a cryptographically secure random. We actually wrote about this when we discovered it and presented a challenge that you can still see here. I mean, this is an old article where we would actually, for the existing container registries at the time, we hid secrets in the various registries and presented a challenge for people to discover them by virtue of just giving them the image IDs. Now, on our end, we actually had to mitigate against this by adding per image ACL checks. And this is still a set of checks that we maintain to this day, even though the more modern protocols thankfully do not have this problem. But as a legacy of the fact that at the time we were writing Quay, we realized very quickly that not only could these image IDs conflict, which would result in potentially getting the wrong data, but you could actually also have a major security problem. Anyway, back to the APA from that little aside, but it's an interesting little point in history. So now we've gotten the configuration for the image, and the next step is to get the file system information. Retrieve the image's binary data. Same idea. Instead of calling /JSON, we call it with /layer, and we get a bunch of binary data back. In the case of Docker V1 and most container images to this day, you get back a tar-gzip that contains the layer data. We've retrieved that, and in theory, we're done. We have the image. But in fact, we have to retrieve the image's parent IDs, because images in Docker V1 are a set of layered images, and there could be one, there could be many. So we retrieve the ancestry, which returns all of the parent IDs of this image, and then we just iterate over and over and over again until we've retrieved the entire set of images, including the whole thing. So we're done. It's actually pretty simple, right? Unfortunately, the downside of this API, ignoring the other security mention, is that the pull operation is fairly simple, but it's also very chatty and inefficient. And not only is it chatty and inefficient, but you have to pull things in order. You can't pull things in parallel, because in order to retrieve the parents, you have to retrieve the child, and you have to do stuff. There were some additional optimizations made in Docker clients along the way to try to parallelize some of these requests, but the inherent organization of the images meant that it wasn't really easy to make it fully parallelizable. Further, as you may have noticed, every image is pullable under this model. So that means that if you have an image that derives from another image, and that parent image is not actually being used for anything but that one tag, you still have to provide a means for pulling those parent images, because every part of the API operates in that fashion. And further on top of that, you could potentially pull an intermediate layer when you didn't intend anyone to be able to run an intermediate layer. So there were some issues with it. So how did Quay represent this data? As mentioned, Quay actually started as a product when Docker V1 was the only API available. Well, we represented it in a fairly simple way. We started with a user table, which today is considered our namespace. The reason it's called user is because when we started, we didn't have organizations. Today, we still represent it in the user table, but it represents a namespace. Repositories lived under a particular namespace or user. A repository tag lived in a repository. This would be latest or whatever. An image would be pointed to by a repository tag. Now, this special check, where an image also pointed to a repository, was where we solved the per image ACL issue. Previously, when we originally started working on Quay, images were universal. There was no need to not share them. But when we quickly realized that they could conflict and there could be a security issue, we rehomed images to specifically live under a repository, which meant that they would never be shared. And then we point an image to an image storage, which represented the layer data for that image. I should note that the image storage is a reference to the layer data in a block storage device, local disk or Amazon S3 or whatever, as opposed to trying to store hundreds of megabytes or even gigabytes in the database, which obviously would not work. So it's actually pretty straightforward, right? We get a user, repository, tags, images, and image storage. Pretty simple. Keep this model in mind moving forward, because it'll influence why Quay as a project became more difficult down the road. Pushing a tag. Pushing a tag is the inverse of pulling. You check V1 ping like we did before. You push the layer contents for each image. You push the config contents for each image. Repeat for every child image. And then you push a tag pointing to the image ID. It's actually pretty straightforward. Notice again that the images are pushed without namespaces or repository names. This is an interesting corner case that we had to deal with when we were trying to build our new security model. Obviously, the HTTP request itself does not contain the namespace or repo for the image that is being pushed. And yet we made a conscious decision that all of our images would live under particular repositories. So we got around this by making it so that when you called the first command to create the repository at the top, we would store the namespace in repository in a signed session cookie. And the Docker client would thankfully pass it back to us for all subsequent calls. And we would then check to make sure that you have access to that repository on subsequent calls and push the image into that particular repository. It was a bit of a hack, but it worked then, and it actually still works now with any client that speaks V1. And once you've done pushing all the images, the final thing you would do is you'd create the tag pointing to that image ID. Note there's an extra check in here called checksum, and what this does is just validates that the layer data you pushed previously matches some sort of checksum. This was actually another later addition to the API. Originally, it was just push the layer, but then when it was determined that there was the occasional chance of data corruption, as with all HTTP requests, that an additional validation check was added. Also pretty simple. And thus, for a time, it was good. So Quay.io launched with Docker V1 support, and we operated in that pretty steady state for probably a year or two. And we would work on other features and stuff, but the core API itself wasn't changing, and that was great. I mean, it meant that we didn't have to worry about other data models, other APIs, besides things that we ourselves were building. But then something new arose. The Docker V2 Registry API. So after the release of the Docker V1 API and adoption by container registries such as Quay, and then Docker Hub, which launched a few months after Quay launched, Docker realized that the V1 API had a number of flaws. I should mention that it wasn't only Docker that realized this. A lot of members of the community did as well. And Docker was very proactive in deciding to address these flaws and come up with a new API. As mentioned earlier, the API issues ran the gamut from the API being very chatty. They were insecure around image IDs. It wasn't content addressable, which meant that you couldn't easily share layers. There's no need for addressable intermediate layers, and yet it was there. And it used very basic authentication and authorization. And as the adoption of Docker grew and more users were deploying containers on their infrastructure, they found that the whole process in particular was a major slowdown in the time it took to start services. And as we were moving towards a microservice world, even in the days before Kubernetes, pull times could be significant. And so to address these, Docker created the V2 API. The V2 Registry API would be designed with a few goals in mind: security and efficiency, specifically via the introduction of a new concept of a manifest. The heck's a manifest, though? We didn't define a manifest earlier. Manifest: a unit containing the configuration and file system references for a container to be run. Wait a second, no, I called that an image before. Why the heck did I redefine it? Well, a manifest is like an image in V1, but unlike an image, it contains everything it needs in a single unit. So previously we had an image, now we have a manifest. The difference is we only have to download the run configuration and the file system information once, rather than having to have this layering effect that occurred before. Manifests, I mentioned, are collapsed. They are also content addressable, which was a key aspect that introduced proper security into the system. So let's see how V2 works. First example again, pulling a tag. Step 0, is this a V2 Docker registry? We do a V2 call, same idea, lets us know we have a V2 registry. It should be noted that, again, every registry call would start with V2. But Docker is very smart. They needed a way of transitioning users. So V2 was not found. Older clients would immediately fall back to V1. And that's part of the reason why /V2 was added. Step 1, get the manifest for the tag. Oops, we forgot auth again. Aside about auth quickly, I'm not going to go into details in it because then this talk would take 2 hours. But Docker V2 auth makes use of JWTs and specific scoping to allow for read-only users versus administrators versus people who have write access. It's really great. It allows for distributed auth. You could have your authentication system be one place and the registry be another. If you're interested in details, look at the auth package in the Quay project. I'm not going to go into it further here. Back to V2. So pulling a tag, you give a token that you've received. You do get /V2 with your namespace and repo, manifest / your tag, and you get back a manifest, a JSON blob describing the entire image. One thing to note is the schema version 1. That's important for later. So what's in a manifest? You have the repo's name, the tag name, the blobs for the image file system. These are the layers, and the history of commands for creating the image. And the blobs are content addressable, usually using SHA-256. And the history contains the history that was used to create this image, as well as any configuration. Note the term V1 compatibility. This was specifically added so that older clients would have a means of accessing the manifest and still converting it internally to V1, as well as for registries to be able to convert down to V1 if necessary. So it's just like we saw earlier with the manifest or image. The run configuration is there. The file system information is there. It's inverted in the order just that I used, but all the information we need is there. And you can even see all the layer blobs inside of the FS layers. Step 2, pull the file system layers. Just call it, and note here again, they fixed the issue. All of the blobs are namespaced via the namespace and repository, and they're all content addressable. And in fact, you're done. And because the blobs are content addressable, you can reuse blobs safely, and you can pull them in parallel. That's it. The Docker V2 Registry API simplified the pull process in a really nice way, and it allowed for a lot of parallelism and additional security benefits, which is why the adoption of V2 was such an important aspect of the community. So how did Quay represent this? Well, we actually chose to add manifest support on top of our existing model. We did that because it was efficient. So if we go back to our earlier model, right, user and repos, tags, images, and image storage, we just added a new table called tag manifest pointing to the tag. And that's where we stored manifests. Why did we do this? It provided easy backwards compatibility for V1. Remember, we ensure backwards compatibility with all new API versions. And it was the ease of addition. It was just add a table and handle it. And as I mentioned earlier, Quay is the only registry to this day that supports V1 and V2 pull and push. You can use any operation on the older clients and any operation on the newest clients, and we will maintain the data transitions internally. Pushing a tag, inverse of pulling again. Check V2, upload all the blobs, push the manifest with the tag. You can actually post the blobs in parallel, and most clients will do this now, and then you just push the manifest. Even simpler than V1. How do we handle compatibility? We created both the tag manifest and the image rows on push from V2. So from a V1 client's perspective, they would just get the image rows. A V2 client would just get the contents of the manifest. So we actually created all of the boxes in purple on a V2 push. So we just did basically the same as a V1 push, but as well for the tag manifest. What about a V1 image pulled via V2? We generate the manifest from the image rows. As mentioned, the V2 manifest matches the same information that we have in our image rows, so we can just bidirectionally convert. So that's good. We're done. Unfortunately, something new rose again. Docker V2 Schema 2. And this is where it gets interesting. But why Red Hat Quay 3.0 took so long? Some history on Schema 2. Remember earlier when I said that the schema version would be important for later? Now it's later. The Docker V2 API had introduced support for manifests and introduced manifest schema version 1 support. Unfortunately, as with all things, as with V1, V1 of the manifests contained a few major issues themselves. Two of the big problems was the manifest contained the name of both the repository and the tag, which meant that if you wanted to add a new tag onto a manifest, you actually had to take the existing one and modify it, which broke content addressability and sharing. They also contained a lot of legacy information to allow for older clients to do conversion. And on top of that, they didn't support other platforms easily. And this is when Kubernetes and Windows support for containers were starting to really enter the community. And it was realized quickly that Schema 1 wasn't going to cut it, particularly around the lack of support for remote layers, which are required for Windows containers. And the last one was there was some legacy cruft in there in terms of a signing solution that had been abandoned. It was still sort of necessary in order for the schemas to validate, but no one was really using it. So as a result, Docker introduced Schema V2. Use the same API, so we're home free, right? No changes to Quay. We can just put it in the tag manifest table, no problem. Unfortunately, that'll be a giant now. What happened? Docker also introduced simultaneously the concept of the manifest list. Okay, what the heck's a manifest list? A manifest list is a manifest that points to other manifests. Very recursive in that way. It was created to allow a single tag to point to different images for different platforms at once. So instead of just having a tag pointing to a single manifest, you could have a tag pointing to a manifest list. And the manifest list could say, if you're pulling from Linux, get this manifest, and if you're pulling from Windows, get this other one. Now, in theory, that sounds like a solid plan, right? What's the big deal then? It's great. Remember earlier when we said we chose to add manifests on top of our existing model. And at the time, that made perfect sense, right? A manifest represents an image. So having a manifest point to a tag and have all the image information makes perfect sense, right? This is our data model we had, and everything makes sense from the time we made it up. Unfortunately, this model implies that every tag in Quay must point to an image, as per this relationship here. But manifest lists aren't images. They're manifests that point to other manifests. Yeah, we're in a bit of a pickle now. And we realized very quickly that our current data model was not going to cut it. And unfortunately, this meant we had to create a new data model. So now we're going to talk about the Quay OCI data model, or how I learned to hate the database. This is the meat of the issue. This is where we spent most of our time. We decided to design a new data model based on V2_2, as we call it, which is Docker version 2 Schema 2. V2 being our little shorthand. We call it OCI for a reason we'll show later. The new data model requirements. We needed to support manifests of different kinds. We had manifests, we had manifest lists. Who knows what the future may hold? We needed to support manifest lists that point to other manifests, so we needed a recursive data structure. We needed to support, obviously, manifest lists without images, and presumably down the road there may even be non-list manifests that didn't have images. It needed to be backwards compatible with version 1, because that's the commitment we've made to our customers. And the one that really made it hard is we needed to be rolled out without any downtime whatsoever. Quay can't turn off support, and we can't go read-only for a week in order to do data migrations. We had to do this without any user-visible disruption on the front end. And this, of course, makes this requirement made everything much, much harder. Because, normally you could just add the new data models, maybe write some conversion code, take the system down, convert all your data, bring the system back up, and you're good to go. So how do we actually do this? Well, this is where it got interesting. This was our old data model, or as we like to call it, the legacy or quote pre-OCI data model here. I'll move this over so you can see it. This was our new model, right? Tags pointing to manifests. Manifests contained one or more manifest child or children. And this allowed for manifests to refer to other manifests and be the children of other manifests. Manifest blob indicated a piece of layer data that was pointed to by a manifest. And that manifest blob would point to the same image storage, which at this point we essentially just call blob, although it retains its name for legacy reasons, as the image rows did. It's actually pretty straightforward, right? There's the old models over there, the new models over there, right? Transitioning from one to the other would be a fairly straightforward process. Fortunately, we had to support both at the same time. So it's actually a little bit harder. We actually had to add compatibility models in order to ensure that we could use both simultaneously. The first one we added is called manifest legacy. This was a mapping of a manifest to its associated legacy image in the database. So if we had a manifest and you tried to pull that manifest via version 1, we'd go look up the manifest legacy image, and if we found one, we'd then continue at the image point, and the same code would operate. Further, we needed a means of mapping our older legacy tag and manifest tables to the new ones. So we had to create other tables, like tag to repository tag manifest to manifest, and there are a few others here that I didn't list, which are listed as transition models, tables that would allow us to map the old to new and basically track where the old things lived and the new things lived. So that if we saw that we had an old copy of something but not a new, or vice versa, we would know. So you can see it's gotten a little more complicated. That's actually quite a lot. Not that kind of a lot. But that's by prefer kind of by a lot. So how did this all work in practice? Here's how we migrated the entirety of Quay.io with no downtime. First, step 0. We interfaced out all registry data model access across the entire code base. We created a new interface called the registry data interface, and any code that was talking to anything in the data model that involved registry would go through this class, or this interface rather. You can see here manifest, blobs, images, labels, etc. And by the way, as mentioned earlier, if you're interested in reading the actual implementation, link is right there. We'll send out the slides after the talk. Note that this took a while given the number of things that access the data registry. And in fact, we not only interfaced out the calls, we interfaced and wrapped the data types. So if you received a tag from the response of a function, that tag would be a data type that could either be a repository tag or a new OCI tag underneath the covers, and our accessors would know where to find the correct information. Next, we added the new data model tables, pretty straightforward. Then we implemented the new data model. So we defined a new data model called OCI model, which implemented the registry data interface for the new data model tables. Same thing as the pre-OCI model, it just talked to the new tables as opposed to the old one. This particular part took a very long time. It required writing a lot of tests that actually invoked both data models with the same test conditions and ensured that they had the same responses. In particular, our registry test suite was invaluable here. Our registry test suite makes use of PyTest fixtures to allow us to write tests once and then actually have them executed with every combination of all the data models, API versions, and schema versions. So in fact, if you go to the the registry test suite right now, you can see tests like this test basic push pull, which the test is pretty straightforward. It pushes a new repository containing some images at a particular tag, and then it pulls the same exact tag from the running registry and verifies that everything checks out. And you'll notice in here there's no reference to V1 or V2, to old data model or to new. But if you run it, it'll actually run every combination of every data model, of every API version for that test. You can see here it'll run, push with V2.1, pull with V1 for the old data model, push with V2.1, pull with V1 for the new data model, et cetera, et cetera, et cetera, et cetera. As you can imagine, this made our CI process very, very slow because we would, at the end of the day, be running close to 1,000 registry tests. But it was absolutely worth it because it ensured that no matter which code path was being taken, we got the same results. Step 3, implemented the multi-write model. So once we had implemented the old data model and the new data model, we implemented a model that called both and actually would write to both simultaneously. We then rolled that out to production. What this allowed us to do was anytime a push would occur on Quay, it would write the data to both the old tables and the new ones simultaneously. This allowed us to start priming for the eventual migration to the new data model, such that any new information we had coming in was going to the new model, so we would ensure it was there, while the old model was still being used primarily by our running production code. Next, we rolled out code to backfill the new data model. Obviously, we had years of data in our old data model that we had to move over to the new one. Backfilling required copying all of our tags and manifests from the old model to the new one, pretty straightforward. But it also required creating manifests for any V1 images that had never been created with manifests. So as examples, if a tag had been pushed in December of 2013, before we had added V2 support, there was no manifest there. And if it had never been pulled since by any V2 compliant client, there would be no manifest. It would have only been pulled by V1. So we also had to create all the manifests for these images as well and validate them before we could translate and backfill. For some numbers, just from reference, Quay.io at the time that we performed this backfill contained approximately 50 million tags that had to be copied from one data model to the other. The backfill operation, including all of the verification passes, because we had automated verification passes that would check that the data matched in both sides, took approximately 5 days, and that was with a beefy size and quite a few machines that we ran in Amazon. So you can imagine the amount of data that we had to transition over, and then verification actually took longer than the translation, but it was critical, obviously, that we verified all of the data that we moved over. Step number 6, we whitelisted support for V2 and select namespaces. This step, in which we spent the longest time, allowed us to debug any issues with V2, the whole new data model, and all of its associated changes without affecting the rest of production, but still making use of Quay.io. So we had internal customers making use of V2, pushing and pulling. If they ran into issues, they were told as part of being granted this access to file bug reports with us. We would then go address them. This allowed our internal exception trackers to determine if there was any corner cases that you're only really going to find with real traffic. And this was a really great debugging tool, but we had to sit in it for quite a long time in order to suss out all of the issues associated primarily with conversion, especially with older versions of Docker. Step 7, selective switchover of reading from the old model to the new model. This is when kind of the rubber hit the road. Once the backfill had been completed and we had verified the integrity of the data and we had realized that internal testing showed that things seemed to work, we started transitioning production users, customers who were not part of our organization, over to, instead of writing to both data models and reading from the old one, to writing to both data models and reading from the new. We started by rolling out 10% of our customers randomly selected via their namespace to do so. And then when we verified there were no issues with that, we rolled to 25%, shortly thereafter 50%, and then shortly thereafter 100%. And this provided a few benefits. First, obviously, if we had encountered a problem, we would only affect a small portion of our customer base. And the second, more important one was this was configurable. So if we found that there was a problem, as soon as we rolled to 25, we could roll back to 10 or 0. And in fact, we had such a case. There was a case where I think when we rolled from 25 to 50%, one customer was being affected with a very specific corner case. And rather than break it for them, we immediately rolled back to 25%, which took them out of the whitelist, fixed the problem, added tests, verified it, then rolled forward again to 50%, saw no further issues, and went to 100. So this was a critical tool in us being able to ensure our guarantees while also migrating. Step 8, full switchover from reading from the old model to new model. This was a scary day, but we had already been at 50%, so we were pretty confident that it wasn't going to cause any further issues. Step 9, disabling of writing the old data model. Pretty straightforward. Once we had everyone reading from the new data model and we had verified that everything was continuing to work, there was no need to write to the old data model anymore. It was now legacy and unnecessary. As mentioned, all new traffic had gone to the new data model. We only kept the old data model for backup in case of a severe problem that was determined down the road, and for garbage collection. That anything that needed to be garbage collected that was still in the old model only could still be do so, and there's a few pieces of legacy information in there. And finally, step 10, enablement of writing V2 for all namespaces. This pretty much entailed removing a MIME type check that allowed Docker clients to start writing V2 to Quay. It was a very exciting but scary day, and I remember it vividly because I was the one who pushed the button that flipped that bit. Finally, deletion of all the pre-OCl code and tests. This is actually one of the best PRs I've ever merged. It was a giant deletion PR. You can see it right here. It was actually only a couple weeks ago. Total project time, 1.5 years. Why the heck did it take me so long to do this? Well, as I mentioned, we had to continue supporting legacy code without any downtime. We had to keep the product performant during the migration. This was particularly difficult because now we're writing to both data models simultaneously. So we had to optimize our queries so that we could make use of some of that optimized performance as per the new writes. There was a number of cross-module changes, obviously, to support the new data model, and then the high risk associated with data migration led to a lot of testing and validation. And while it meant that the project took longer, it was absolutely worth it because we caught a lot of problems that would have otherwise severely affected customers. And overall, the rollout went without any major issues. What about Red Hat Quay on premises, right? We offer Quay not only as Quay as our hosted service, but on-prem as well. Our on-premises solution, which is the same code I might mention, Red Hat Quay is the same code that is used on Quay.io, use the same exact migration code. We provided a background upgrade compatibility mode flag. You set it in config, boot the product. It would add the new data models, run the backfills in the background, verifying along the way. And then once it had finished, you could just then flip the final a config flag, which would run the final migration, and you're fully on V2 too. So it was all of the work that we did to enable Quay IO's migration without downtime had a nice side benefit that we didn't have to redo that work, so that our customers on-prem also didn't have to have downtime for the upgrade. In the end, though, it all worked. Thank God, because it was a heck of a project. So that was pretty much our journey from the beginnings of Quay to our current implementation. But I did mention something about OCI. While we were working on this process, the Open Container Initiative, which is the standards body set up to manage the standards around container images, started working to standard the V2 API and manifest format as the OCI distribution spec. This spec and protocol will actually be standard soon. It's actually not standard yet. And thankfully, it only comes with very slight changes from V2. It uses essentially the same API, essentially the same manifest format with some slight modifications. You can read the spec here. And in fact, Quay has recently, and by recently I mean literally yesterday, merged experimental support for OCI manifests and indexes, i.e. manifest lists, they renamed them. So all of the work we did, all of the pain we worked through has actually led us to the point now where adding support for even more stuff, i.e. OCI manifest and index, was a very small change. You can actually read my PR that I submitted yesterday, and it's only, I don't know, a couple hundred lines of code. Thus, we arrive at today. So our data model today looks like this. There is the repository and the user tables that are off screen. You can see we've gotten rid of the transition tables with the exception of manifest legacy image. We've gotten rid of repository tag, and we've gotten rid of a few other tables as well. Those tables still are in the code base, but they are not being written to. They are only there for legacy reasons for GC. And over time, we are moving towards full deprecation and removal of those tables. You will notice still that we have the manifest legacy image and image tables. These are still in support of Docker V1, which means there are a few small steps remaining. Chiefly, the next plan is to remove the image table entirely, and instead, when V1 code asks for pulling or pushing, to have it actually synthetically generate images from the manifest data that it pulls, and then get rid of the old mapping tables, which will be basically just execute a migration to Drupal. That's all, folks. I know there was a lot there, so I'm sure there's questions, so I just wanted to provide that time now. I'm going to stop sharing my screen so that...
There are. We have time for a couple of questions. Let's see. We're still getting screen sharing from you.
1 second.
It's just blank, that's all. There we go. Perfect. Okay, terrific. So, first question, the obvious one, Quay versus Key. What caused you to choose a project name that was going to cause pronunciation arguments for its entire lifetime?
Right. So I will state for the record, I was the one that named Quay. It's named after the part of the dock that the containers are unloaded at and held at before they go onward into transit. I felt it was very applicable to a container registry. Why did I choose a name that would have such pronunciation issues? I didn't know that it was pronounced otherwise across the world. And my personal philosophy on the subject is Quay, Key, K, Kai, pronounce it however you want so long as you use it.
Cool. Thanks. Second question, is Quay ready for a fully disconnected install? And if not, is that expected?
So
by the way, let me interrupt you. In case we need him, Dirk Herman has dialed in, also from the Quay team, has dialed in for roadmap questions.
So Quay itself can work in a fully disconnected environment setting as long as the storage and database are obviously behind the firewall. And in fact, you can even use it in scenarios where there's selective network via repository mirroring. The thing that Quay can't do today is twofold. First, Claire, our security scanner that Quay uses in order to scan container images, Claire V2 was not designed for disconnected environment support. However, we are launching Claire V4. It is going to enter tech preview with the launch of Red Hat Quay 3.3, which, as mentioned, should be coming out next month. And while it clarity for today does not support disconnected environment. It is one of its primary project goals, so it will soon. The second issue today is Quay's repository mirroring feature does not allow you to load from disk. It requires network, so it works in selective network environments, but does not work in a no network environment. That, however, is a roadmap goal, and it is on our roadmap for the near future.
Okay, thanks. From Jorge wants to know, can you tell us more about signing images?
Sure.
Are we planning to support Notary version 2? Is there some other scheme that we're using? Is there a way to make it more user-friendly?
Sure. So I'm not going to get too deeply into it because we're pressed for time, but Docker Notary is a signing solution based on Tuf created by the Docker team many years ago. It was haphazardly adopted by the community due to some non-insignificant user experience issues. The community has recognized that it has problems and has formed a new working group for Notary V2, of which I am a member, and as is other members of Red Hat. And the long-term goal is, yes, to support Notary V2 out of the box once we have a working standard. Notary V2 as a concept only really started at KubeCon EU in last year, around this time. So we're still very early in the development cycle of that standard and specification. So realistically, the time frame on it is probably no less than another year. In the interim, Quay.io does support, in a tech preview sense, the older version of Notary, and the code for using it is there in Project Quay. So if you want, you can use Docker Notary with Project Quay today. We do not support it with Red Hat Quay because of the aforementioned usability issues, specifically around key rotation, but I can go into that in more detail if necessary.
Cool. Okay, thanks. So I think we're going to do one last question because we are well over time here, which is Emilian wants to know, are there any plans for an easier to install standalone version of Quay? Because Quay currently requires both Redis and MySQL containers running as well, which makes it more elaborate to install than the Docker registry.
Yes, so there is already a Quay operator that is in tech preview that we've been working on that will install portions of this via other operators. The long-term goal for Quay is to get to the point where running the Quay operator, you would create a Quay registry custom resource, and it itself would then in turn go create the database via database operator, Claire via the Claire operator, Redis via Redis operator, and that would be all she wrote. We're not 100% there yet, but we're close, and pieces of that are already present in the tech preview Quay operator. So my recommendation is, if you are running on OpenShift or even vanilla Kubernetes, try the Quay operator today. It works. It doesn't yet handle the day 2 operations, but it does handle the installation and setup portion, in particular running database in Claire.
Okay, well, thank you very much. We are at time. We're actually past time. So thank you for that tremendous deep dive into the history of container registries. Where can people find you if they didn't get their questions answered?
So we are on, anyone who is in Red Hat has access to the CoreOS Slack. I'm in there. And for people who are external, we have the Project Quay discussion information, which can be found at projectquay.io. And you can send questions in there and they'll be routed to me. I'll be happy to respond.
Okay. Well, thank you very much. For anybody who missed anything, a video of this will be up on the Red Hat Community YouTube channel later today. Coming up next in Community Central this Thursday, we have a member of the Ansible team talking about the process of refactoring how Ansible collections work. And next week on Tech Tuesday, we're going to be introduced to Cogito with a K, a new Kubernetes-based project for business logic. So once again, thank you very much, Joey, for that. And thanks everyone for joining us.
Thanks everyone for watching.